Next curve.
Everybody, welcome to this episode of Next Curve's Rethink podcast, where we break down the latest tech and industry events and happenings in the world of semiconductors and Karl's favorite topic, AI. And Jim's, right? Yeah.
Absolutely.
Yeah, and we break all this stuff down into the insights that matter. And I'm Leonard Lee, executive analyst at Next Curve, and I'm joined by this wonderful individual named Karl Freund, who is the center of the Cambrian AI event that's happening right now. And he has a company called, or a firm called Cambrian AI Research. And we also have the dynamically foveated Jim McGregor of the famed Curious Research. How do you like that one, Jim? I learned that at GTC 2026.
Oh, geez.
I have no idea what it really means, but it is a thing. It's called dynamic foveation. So
I'll have to look that up.
Yeah.
Jim should thank you or hit you.
Yeah, it's really an interesting collaboration between Apple and NVIDIA in the whole spatial computing space. So really exciting stuff. But, I always associate Jim with really exciting stuff. So, gentlemen, welcome.
Thank you.
Yes, and so you're probably wondering what we're going to be talking about. Well, I already gave you a hint. GTC 2026, we're going to do a recap, and I'm going to have the pleasure of listening to these two gentlemen who were on the analyst program. I was not this year. And I'm really curious what your takes were, since you were there front and center with the program, and I was out in the exhibition hall running around trying to find free lunch. But before we get started, remember, please like, share, react, and comment on this episode. Also, subscribe here on YouTube and Buzzsprout. Or listen to us on your favorite podcast platform. Opinions and statements by my guests are their own and do not reflect those of Next Curve or myself. And we're doing this for informational purposes only, to provide a open forum for discussion and debate on all things AI and silicon, semiconductor, and supercomputing. So, by the way, hey, look what happened. Got one of these. 100,000 subscribers, and I wanted to thank all of our subscribers, but also Jim and Karl for their wonderful collaboration on the Silicon Futures series. Gentlemen, I attribute a good portion of this to some of the great insights and collaborations that we've done over the years on this program. So thank you so much, and congratulations, because part of this
congratulations to you
guys as well.
That's pretty cool.
Notice he didn't send us one. No, just kidding.
No, I didn't. I'll go check my mailbox.
I'll get you guys one. But what I want everyone to do, though, is recognize you, and also reach out to Jim and Karl for their insights. They're absolutely valuable voices and eyes and ears on the industry and what's happening in AI and the semiconductor industry broadly, or even beyond. So yeah, definitely reach out to them and stay ahead of this very quickly rising tide of AI that's sweeping
It's not possible.
Everything.
It's not possible. You can't stay ahead of it. It's impossible.
No.
OpenClaw just proved that.
Short. I'm trying to make you look good, Jim.
OpenClaw proved
What's your
it.
problem?
I was telling Jim, I've been working here on the new house in Tucson, and I totally missed the importance of OpenClaw. And I got to GTC, and I'm like, holy cow, the world just changed while I was changing light bulbs here.
He's looking at me. He's like, Jim, why didn't you tell me about
Why
OpenClaw?
didn't you call me and tell me?
I thought you knew.
So, hey,
Take off for a few weeks and the world changes. Yeah.
Yeah. Let's get, you brought up OpenClaw. So, what stood out this year?
That was
it
probably
was a
one of
big
the biggest
event.
things that stood out was OpenClaw or NemoClaw, I should say,
NemoClaw.
which is NVIDIA's wrapper, kind of security wrapper, along with their is it Open Box or
Open shelf.
That's a
Open shell,
sandbox.
open shell.
Open
But
shelf.
basically, the open shell, the entire NemoClaw solution is designed to put a wrapper around OpenClaw, and OpenClaw is, very, very innovative in the fact that it's basically an agent to call other LLMs or to call other tools and everything else. It's the easiest way we've had so far to build custom agents personally and actually on device. Yeah. So it's a major innovation. Unfortunately, and we've played with it, it has its limitations. It can go rogue because you don't really alter the code when you give it rules. And those rules can be forgotten over time, especially if you're running into memory limitations. So it has some serious security limitations. Well, NVIDIA recognized that, came out with NemoClaw to kind of put the security wrapper around it. Very innovative, along with tools like LangChain, the fact that you can build these agents so quickly, so effectively, in a very short period of time to do pretty much anything you want. And they can operate on device or in the cloud.
Yeah, maybe a hyperbole, but gosh, my lake is shifting. I need to straighten the picture.
That's right.
It may be an overstatement, probably is, but to me, this is the killer app.
Yeah,
we've been waiting for a killer app for AI for 5-6 years, and we thought it was ChatGPT, but it's kind of hard for a lot of people to make money off ChatGPT. OpenClaw, I believe, is the killer app of Agentic AI, and it's interesting. I can't imagine what it must have been like to work at NVIDIA for the last 3 months. Because 3 months ago, NVIDIA did the unthinkable. They decided that GPUs weren't the right solution for something, and that something is called Agentic AI. They wanted to get on top of that. They previously were working on the front end of inference processing, the large context prefill problem, and they came out with a product, announced a product for that called CPX, Rubin CPX.
Yeah,
and then as Ian Buck said, along the way we found something better, something different. It's not solving the large context prefill problem. It's solving at the other end of AI, which is token generation at massive, incredible speed and very low latency, and importantly, deterministic latency offered by Groq language processing units, LPUs. In the last 3 months, not only have they integrated these new engineers and leadership into their team, they've taken their next generation chip called Groq 3, Groq 3, LPU3, and so they built an entire rack, NVL72 kind of rack for them, and them as they now. So they have now shifted strategy to focus on agentic AI as opposed to what they were focused on and still are, which is the large context problem with, let's say, using movies, video as an input token, okay, or body of code. A million lines of code, using that as near input sequence. They're now focused on agentic AI, and they're going to have probably anywhere from 1 to 4 racks of Groq LPXs alongside a rack alongside a Rubin. Right, so you're going to have a Vera Rubin rack, and you're going to have like anywhere from 0 to 4 LPX racks for each Rubin rack. And it's like, wow, this is a major shift. This company has been so focused on GPUs. You got a problem, we'll solve it with GPUs, right? Yeah. No. This company was amazingly agile to be able to say and fully believe, no, this is not the right problem. GPU is not the right solution for this problem. Groq has the right solution for this problem. It would take too long to acquire the company, so we'll just acquire its assets and leadership team and engineering. Yeah. So, well, it is pretty damn amazing.
On top of that, they were coming out with a storage rack solution, the SDX, and even re-architecting future generations of racks with Kyber to where they're actually going to have blades so they can double the density of GPUs from 72 to 144 and get away from using cables and actually using backplane solutions. So, I mean, the level of innovation is just phenomenal that we see going on at NVIDIA. Jensen likes to say that NVIDIA innovates at the speed of light, and it definitely looks that way.
That speed of light, I haven't heard them talk about speed of light much lately. When it was first discussed, it was more than just speed. You're absolutely right, Jim. They're moving at amazing speed. But it is the idea that your competition is not another company. Your competition is fundamental laws of physics, like the speed of light.
Yes.
So if speed of light is perfection, how close can you get to perfection given the technology you have today, the resources you have today? How good can you get? Forget the competition. NVIDIA guys don't think of competition; they think of the speed of light.
Yeah. Well, that is a huge shift, and I know that during the keynote, he was mentioning CUDA quite a bit. In fact,
it's 20 years.
The whole thing.
20 years.
Right.
20 years of CUDA.
Right, but like, what's really interesting about the comment that you just made, or the assessment that you've made, Karl, is this huge shift away from the GPU, and I think that was really noticeable. But also, it wasn't just the LPU. They introduced the Vera rack, so now they're making a big play into CPU. And so all of a sudden, we're seeing this big change in the quote unquote accelerated computing story where I think 2-3 years ago, the impression was everyone's going to move everything toward these quote unquote GPU infrastructures, right? Now, it looks like CUDA might not have that kind of scope.
So I would put a little different. I'd put a little different spin on it. I don't think they're moving away from GPUs. I think they're adding things beyond the GPU to the GPU-based solution. So if you look at inference from NVIDIA a year from now, you'll have racks of GPUs, all with all their fancy NVLink and everything. You're going to have racks of CPUs, which is Vera, and you're going to have racks of LPUs to solve the agentic AI problem of lots and lots and lots of small models, all calling each other. And so it's a much more heterogeneous environment. I don't think it's moved away from GPU. I think it's moved beyond GPU.
And I think if you go a step further...
that's a huge statement right there, because in a lot of people's minds, NVIDIA is a GPU company.
Yeah,
GPU, and I put it in quotes because
not anymore.
We're not just talking about the chip.
They really are, and I think if you take it even a step further, they continue to look at the workloads, which are changing rapidly and very, very quickly, and they're trying to identify the bottlenecks. So, I mean, last year they, along with Micron, introduced SOCAMM memory just to address the KV cache issue and everything else. They introduced a storage solution this year to also address some of the storage specific solution or needs that you need for AI, not long-term storage, but AI type of storage, that short-term or mid-term type of solution. And they keep looking at that, and it goes beyond just even the hardware. I mean, the fact that they continue to look at enhancing foundational or frontier models for specific types of applications, especially for the physical world. And the fact that they now have over 1,000 CUDA-X libraries for modeling pretty much everything from DNA, genomics, all the way to the planet Earth. I mean, basically really looking at, is it hardware, is it software, is it interconnect, what is it, what are the bottlenecks, and how do we get over that? And we're even seeing that with next generation platforms with Kyber going to those blades and everything else. It is amazing that one company has this breadth to look at what has to be done to address these needs.
I thought, for me, the sparkling moment of GTC when Jensen went home and told his wife, "Hey, today I announced we're going to do $1 trillion in revenue. And so what? No
Take
big
out
deal.
the trash.
That's exactly. Take out the trash now, Jensen. I've been telling you for days. You got to take out the trash. That was his wife's response, supposedly. And if you look at what the stock market's done, it's done the same thing. $1 trillion. So what?
Yeah. Well, there's a lot of big numbers being put out there, but I know that you guys are very bullish about all this stuff. But
there's no but. There's no but.
Yeah, no, there is a big but. There's a big but. There's a big not with two T's either. Actually, there might be. Anyway,
it might be one of those two.
But no, I'm definitely one of the overhanging clouds of this conference is circular investment. I have a lot of discussions about that, so we can't discount that. Even though from a technology front, there's a lot of excitement, but from an ecosystem standpoint, I mean, one of the things that I don't think really was well received was a comment that Wall Street is there. There's more Wall Street people or investment or finance sector people there than developers. And so I think the conference itself has changed a lot. We saw that with the event last year. I don't know if they had a Q day this year.
No, they did not have a quantum day this year.
Thank God. I thought that was terrible. And then next, CES also less focus on technology, more on the markets. But I think the important thing here, though, is when we look at the transformation of the company, as we're alluding to through the comments that have been made so far, NVIDIA is dramatically changing. There's obviously a huge reaction to the diversity and the complexity of the inference opportunity, and this is stuff that we've actually been talking about, quite extensively in prior episodes, whether it's related to the memory architecture or the role of application specific silicon in presenting a different envelope of optimization for some of these these models in runtime. I think it's you guys mentioned adaptable. The identity of the company is evolving really rapidly. Last year, it was all about, hey, we're an AI infrastructure company, right? This year, AI factory seemed to be that identity that NVIDIA wanted to portray or at least push out there. I don't know. What do you guys think?
I don't think it really changed. I think they still they may not have mentioned AI infrastructure as many times as they did last year, but I still think that's the focus. They want, and more than anything else, and Karl can speak to this, but we're seeing more of a message around not just hardware, but obviously software and tools and everything else. And support for the entire ecosystem, like the STX. They're not coming out with the STX. That's going to be up to partners to actually develop that rack. And the fact that all these models and all these libraries are now open source.
Well, and speaking of the STX, well, I mean, they're pretty stringent on the requirements and their adherence to the reference designs, but one of the things that I think is interesting is last year it was about GPU optimized storage, right? It seems like, Jim, what you're saying is this year's, let's say, evolution of that idea is AI optimized, right? Because when we're looking at agentic, the workloads are more expansive. They're not singularly focused on just the AI element. When we look at
the key problem they were solving is that agentic AI has to an agent's working on the job you gave it has got to work continually in the background for days, weeks, or months, and so you need all of its storage, that agent's cadre of other agents. They all need very fast storage to be able to continue to work on that problem until completion.
Yeah.
And so when we talk about AI, we think in terms of asking ChatGPT something, right? Well, that's a one-shot deal, and once it's done, it's done. So the storage required for that only exists for, a few milliseconds, whereas an agent may need to have its storage close by for weeks or months. And there wasn't a good solution for that until NVIDIA came out with the STX. So it's a really different animal. Again, everything's being driven right now from Agentic AI. I can't say that often enough.
Well, last year we talked about we made that observation around tiered memory, and then the very bottom of that tiering was the storage bit, right? The GPU optimized storage for long memory, right? Mm-hmm. And so, Jim, since you're like the super technical guy, what did you see changing there in terms of the thinking around the memory tiering? Because, that was such a big deal through the course of last year.
Well, it was. I mean, they came out with SOCAM, and it was a proprietary, basically, architecture last year developed between Micron and NVIDIA. And within a year, it became an industry standard. And we're seeing not only interest in it from anybody else that's doing AI accelerated platforms, but even from like HPC applications. They don't want necessarily the high density, but they want the high bandwidth. So they're looking at it for kind of lower density configurations. So just the fact that that's become a new level of hierarchy within the memory hierarchy to support KV cache. And we were already talking last year about GPU attached storage. Well, now essentially what we have with STX is accelerator attached storage, and I hate to say GPU because now we have the LPU and everything else, but you have that storage solution that's really dedicated to those AI accelerators to be able to handle and perform those solutions, in addition to that changing memory stack that we're developing.
Yeah, at the risk of self-promotion of the idea of Cambrian explosion, we're seeing a Cambrian explosion of the heterogeneity of AI solutions. Not one solution, one size will not fit all. No. And I think Jensen realized that, and really that's what drove him to expand his portfolio to CPU racks and LPU racks, along with the GPU racks and storage racks and network. It's just it's a remarkable shift that I don't think the market fully appreciates right now. Most people don't appreciate that right now. And then, Leonard, kudos to you and your platform for helping more people understand what's really going on here. It's a major ground shift.
It's you guys as well, and the fact that we had these debates instead of just agreeing with each other. I think that surfaces those salient points that hopefully shapes a better dialogue around all this stuff, but helps people maybe think in more lockstep with what's going on. I mean, so thank both of you guys. And again, congratulations. You guys are all part of this achievement here with the YouTube channel. But no, you know what? Here's the thing, though. I really don't think Jensen knew what was coming down the pike. I know a lot of people love to think that, but here's the thing. Let's go back to the roadmaps that he's laid out over the years. Mm-hmm. This stuff was not part of the roadmaps, and he was very vocal about saying that we give you assurance that over a 4-year period, you guys can depend on us to have that reliable roadmap that can guide your investments. What we're looking at now is kind of it's turning into a much more complicated outline, even for AI supercomputing. And I think you guys made the comment about adaptability. Yes, they're adapting really quickly. And one of the things I'm noticing, even with some of the hyperscaler plays, whether it's Maya 300 or Ironwood or Google's whole line of TPU systems or it's Trainium, everyone is trying to adapt. And we're seeing roadmaps as well as platforms that are transitional, right? And the way I looked at the Groq 3 LPX system, it's kind of like a weird add-on to a Vera Rubin. And you mentioned, Karl, you're going to have a Vera Rubin and then maybe 1 to 4 LPX racks.
Actually, we should specify you're going to have a Vera, you're going to have Rubens, you're going to have STXs, you're going to have LPXs. Yeah, so you're going to have, and eventually you're going to have CPXs. So yes.
Yeah. And CPX will be a part of that as well for some customers.
This is a lot for customers and the industry to digest. I mean, we're going away from what looked like 3 years ago, a very simple looking and extensible roadmap to something that, to your point, Karl, has become very heterogeneous and really a diverse stack to meet a wide range of domain-specific requirements or even function-specific requirements. And that was something that really resonated with me in Jensen's talk, is that he actually gave props to application-specific stuff, right?
Yeah.
So anyways, at least that was my take. I don't know how you guys...
I think it fits in with that whole view that the new unit of compute is the data center, and the fact that, we would have thought about this as a single server. How do we architect a server, 15, 20 years ago? How much memory are we going to put into it? What kind of storage? What type of processor? Do we put an accelerator in? Now we're at the point where these functional blocks are entire racks. And we're thinking about the data center as one unit of compute, and really, how do we build this system? What pieces do we need to put in there? And so, I mean, I don't, and let's face it, if we went back 30 or 40 years, it was, what components do we put together? And then it went into an SoC, and then it was, so I mean, we continue, I think, building this. I just think that it's gotten to the point where and you have to remember that we're now addressing problems. When you think about simulating the human genome, when you think about simulating the Earth, when you think about simulating anything physical, we're now reaching into areas of scientific research and analysis that we only dreamed of, previously. So I mean, we're building systems bigger and better than we ever have, but we're also addressing things. I mean, just look at what we're doing with AI and multimedia. And the fact that we now really have realistic AI generation capabilities for entertainment and gaming and stuff like this. I mean, it is amazing what we can now do. And the roadmap just keeps taking us to where we're going to be able to do more, and we're going to be able to do more with less. Because I mean, from what we've seen, every year we're seeing about a 10x improvement in efficiency. Just in terms of the model sizes. So the model sizes are coming down 10x. At the same time, the performance of these systems, or performance efficiency of these systems, is going up 10 or 100x. So we're seeing 1,000x improvements in capabilities and efficiency almost every year.
Almost every year. Well, almost every year. It's mind-boggling.
I had an interesting conversation actually on my other podcast, IoT Coffee Talk, about that performance versus scaling. And this is where things like times X, whatever, 100 times or a million times, that, there's some charts that Jensen was showing. I think one of the things that oftentimes gets conflated is the difference between, the scaling versus performance. With performance, I mean, it's really about do you have more efficient compute, and are you able to then have that more efficient compute in a system that can maximize the density or push the envelope with density, right? Whether it's innovations on the thermal front or the power or compute, right? And then you have scaling, which is the scale out. It has been really been pushed forward with scale out and now scale across, right? And so some of these times a million or larger, multiples that we're seeing are typically on the scaling of the size of the clusters or that are now spanning data center campuses, right? And so I think it's really important to have that proper lens as we're ingesting these large multiples that people are throwing out there. But I don't know. When it comes to
I think of it in the same form factor, and I'll be honest with you. I do see, anywhere from 100 to 1,000x improvement in the form factor every year. Matter of fact,
really?
that's one of the issues I have with. I was at Embedded World and MWC. And I'm talking to the network guys and saying, listen, we need to make the network part of the platform, part of the workflow. Because in many cases, like physical AI/robotics, it has to be the intelligence. It has to be the kind of the backbone of the solution, because you're only going to be able to put a robot has a form factor, it has a power budget, it has all these things and a performance limitation. You're going to want a lot of that intelligence in the network to do the sensor fusion between all these different hundreds or thousands of sensors between robots and other sensors. You're going to want it to be able to do the orchestration between all these different units. You're going to want it to do LLMs that you can't do on device. And you're going to have to be able to do that in sub 1 millisecond timeframes. You're going to have, so I mean, the network, whether it's a router, whether it's a RAN, whether it's whatever, has to be able to do that. And it has to be able to handle 1,000x increase in data. And some of them looked at me and said, oh, no, we're going to do all that in the cloud. I'm like, no, you're not. And some of them looked at me and said, well, we'll get there with 6G. I'm like, no, you need it tomorrow. I don't think they get the urgency and the need and the fact that, we really are. You talk about, we are seeing some of these astronomical numbers thrown out there for 1 million X and everything else with these data centers. But quite honestly, when you look at the amount of data that's being processed, it is literally increasing 100 to 1,000x every year. And it has to be done in the same form factor.
Right. Yeah. And so that's the volumes. But if if there's a suggestion that generation over generation, we're seeing these large multiples in terms of performance. The other topic that was debated pretty heavily, at least I was doing my own thing. So I wasn't part of the analyst program. I don't know how much this was talked about, but the whole obsolescence topic, right? When you look at something like that in terms of a generational improvement, it really makes the whole, hey, you can extend the useful life of any investment 10 years really untenable. Because at the end of the day, it's not about how do you repurpose. You can repurpose things. People do that all the time. It doesn't mean that let's say that you get 100 times improvement on the OpEx and with the energy efficiency in producing a token. That alone makes the prior generation obsolete because it's 100 times more.
But that's not what's happening. But that's not what's happening. The cloud price of Ampere. Remember Ampere?
Yeah.
Okay. The cloud price of Ampere is increasing, not decreasing. So that tells me
demand is outpacing it.
Thank you, Jim.
Right.
Exactly right. Demand is
there's the price, but the question with everything related to monetization is it profitable? And the question is it profitable to run that workload on Ampere versus Blackwell?
You fully appreciated the asset. Of course, it's profitable. You fully appreciated it. You fully appreciate it. The only cost really is power.
Yeah.
Right. So Ampere's what, Jim, 6-7 years old?
Yeah.
Right. So the cost, you have to factor into OpEx as well. But then if it costs 10 times more to run that workload from an OpEx perspective on Ampere versus Blackwell,
But if I can't get Blackwell, if I have more work, to Jim's point, if I have more work than I have capacity, of course I'm going to use that Ampere. It's fully depreciated asset. So I have to disagree, which is what I love about these conversations.
Yeah, well, no, I know, and that continues to be what I call Jensen's paradox, and I think it's going to continue to be a question, because I don't think people factor in the OpEx end of it, and then also the idea of obsolescence is
of course not factor in the OpEx. I mean, these guys know how to use spreadsheets. So.
I think you're bringing up the key issue, and this is, the fact that obviously there's an entire ecosystem, there's an entire value chain, and everyone needs to have a positive return on investment at some point in that value chain. Yeah. And that's brought up the whole question, especially by the financial community, of is there an AI bubble? Well, in terms of demand, there is no AI bubble. As long as I can see, or that we forecasted, we have wave after wave after wave after wave coming. That is pushing just the demands that we have that are up astronomically. But, does that mean that we have the business models in place for all parts of that value chain to make money effectively? That's a good question. And I don't know, and I think you do a good job of bringing that up, Leonard. I don't know that all parts of that value chain are really set up to effectively do that.
Yeah. And that is still the vexing question for the industry, right? And then it's not just about monetization, it's profitable monetization. And, in terms of one of the things, especially for, here's another topic that came up, especially as it relates to Agentic FinOps. The economics of Agentic is not well known. One of the things that I'm hearing quite a lot these days from the developer community is that the unpredictability of the cost of work when you assign it to an agent. It's inconsistent because you never know. Like say, for the same unit of work, the cost can vary dramatically. And we have to still remember these things can still confuse themselves and get into these infinite loops.
Well, and we have agents using agents, so you never know how many agents it's calling, or how many models it's using, or how much data it's using. Matter of fact, you can ask the same question twice of an agent, say, well, I want more detail, or are you sure about this, just to make it double check itself, and that changes everything.
And Jensen had an interesting concept that I hadn't heard of before, I hadn't really thought about, which is when you hire an engineer, you need to give that engineer a token budget. Okay. And you make sure if he doesn't spend his token budget, he's out of here. Right. Because that means he's not being as productive as he could be. But to Jim's point, he could also rapidly outspend his token budget and become a cost problem. So I think this uncertainty is something we'll have to live with for a while. Yeah. But it will be solved.
There's the efficacy of how tokens are spent. It's good that he brought it up, but there's a big question about what is the value of a token, not from a cost perspective. The cost perspective, the cost of each token, depending on the system, is somewhat predictable. But at the application level, it's completely unpredictable. It's very difficult. Whereas, let's say for a deterministic system, you have for transaction costs and pricing that can be calculated. But how do you do that when you're using agentic systems? It can be variable and very, very dramatically different. So the variance can be different. How do you cost for it? So the whole FinOps topic, I think, has largely been avoided because of exactly this. And then it also introduces risk to the value conversation around agentic AI. But anyways, I think this is something we'll probably be talking about great topic next year. Next year. This year, denial.
I agree. I think right now
it's a great topic, and it's great that you keep bringing it up, and that you've made it a key focus, Leonard. It really is.
Yeah, I think we'll remember this year as the year agentic AI became real and possible.
Yeah. But
we'll worry about the economics down the road, right? Now, people are saying, "Oh my God, I like the way Jensen put it. He says every company needs to have a strategy for Claw, for OpenClaw." And the more I thought about that, I thought, "Wow, he's right. This is that transformational. What is your OpenClaw strategy?" Everybody from IBM to Pillsbury.
We're even working on it. Matter of fact, we've been working on it for a month.
Yeah.
And the first thing we found out was OpenClaw was dangerous.
Yeah. Oh my God.
Exactly.
I love that. Yeah.
I like the way that NVIDIA says when you set up your OpenClaw, it has zero access. Yeah. You have to grant it access. It can't inherit your ACL, right? It can't inherit your capabilities. You've got to give very specific, very fine-grained access to very specific files and data. Or Jim's right, it's going to run amok. It's going to put you out of business.
Although I will tell you, I discovered some really, really interesting things about true readiness of being able to sandbox, even put together a sandbox environment. So it's not stuff that's publicized. It's stuff that's in my research and the discovery that I did at GTC. So clients, if you want to find out, give me a ring.
Yeah.
But here's the thing. I want to give a shout out to all the people who have been doing agentic on device. The likes of Apple, Google, Microsoft, and Lenovo, Honor, all these guys that have been looking at on device and trying to figure out how to do personal AI. And Jim, you alluded to this earlier, that this is really about on device and doing something more localized than, your own thing, right? This stuff is really hard. And one of the things that I really struggled with when Jensen got up on stage and said, this is enterprise grade, prove it. Because these other companies have been struggling with this for 2 years, right? And they're being labeled as being behind and all this other stuff. But, now you have this very dangerous thing called OpenClaw, as you mentioned, Jim. And then in 2 months, probably at best, now you're going to come and claim that this is enterprise grade. The chart looks great. I'll tell you right now, most people don't even understand this stuff.
That's true.
Much less know how to secure it. And what I want to see in 2026 is NemoClaw to prove its claims. I'm not believing this stuff face value because
we're working on that now. So give us a month and we'll see.
Yeah, see right here, and you're gonna
right here.
Us.
We're doing it now. We're doing it live.
Exactly.
We got 3 software developers on staff.
And hey, and to the audience, if you want to know what's up with all this stuff, because this is probably the most important question coming out of GTC, Jim and his freaking amazing kids and the developers and the team there, definitely you have to talk to Jim. But one thing before we call it wraps, Jim, I wanted to get your take on AI Grid. Did you have any points of view on that? Because that for the telco industry, it's a big thing. There's a lot of headlines about it. There's a lot of attempts to associate it with some sort of game related to AI RAN. But I mean, what was your impression?
Well, I'll be honest with you. I was still rather disappointed. Obviously, there were a lot of MWC was all about AI RAN and how we're adding AI into the network, especially with 6G being basically an AI defined solution. However, and NVIDIA had a big announcement with Nokia and several telcos over there in Europe talking about AI RAN. I think that the telcos and the equipment companies start to see more opportunity to integrate intelligence into the network, but they're still looking at it from a network management perspective. In other words, how do I more efficiently run my network? How do I do this? How do I do that? I don't think that they truly see the opportunity, and they need to. I really think that the business model for the telcos has to change. And we've been telling them this for over a decade now. But the fact is that 6G may be the last truly defined network, because they're going to have to be upgrading their networks, whether it's hardware, software, or both, every 2 to 3 years going forward, just to keep up with this demand. Once again, like my robotics example, the network becomes a critical part of the workflow of the platform that you're looking at. In a lot of cases, you have to do the intelligence in the network because you can't afford to go to the cloud for deterministic applications, for applications that just require low latency. A 10 millisecond delay in a robot can be very hazardous. You can't afford that. You have to have sub 1 millisecond. So, I mean, I think that, and I stood up in front of a whole crowd in front of the Nokia event and said, I don't think you guys have a sense of urgency. And I really don't. I think that I think that they need to get urgency. So I still think that the network, and it'll be interesting, because I think this is an area of innovation. And if the traditional equipment guys and telcos don't rise up to the task, somebody else will.
Yeah, and I love the fact that you were the last person to ask a question. I was like going, "Oh my God!" So there he is. I've been seeing him this whole time. Oh my God! And you were telling, what did you tell the mic handler when I was up there asking?
You were right before me, and he was trying to hand me the mic. I says, "Oh, don't worry, he's going to ramble for a while."
I love that, but my question was actually pretty short. But you know what? You keep bringing up networking, and I guess we'll wrap up with this. I'll just make a comment. I didn't hear too much, which was really weird, given I think we all recognize how important networking is and interconnect is for the continual scaling, especially when we look at all this heterogeneous stuff. The networking has to look really different. It's not going to be GPU or the old roadmap centric. It's got to diversify. But the CPU stuff, I was surprised to see the semi-committal push for the CPU stuff, and they introduced a new rack, switch, right? The Spectrum X.
I'll be honest with you. I'm seeing more interest, I think, more pull on the CPO stuff than I am push. So instead of seeing the push, I think maybe from NVIDIA and other technology providers, I think the end market is going to pull that in even quicker. So I would agree. I was surprised I didn't see more from it, maybe from NVIDIA, but I still think that opportunity and that demand is there, because I think the hyperscalers and the neoclouds and all these guys building data centers out realize how much what the value of that is from a complexity perspective, a cost perspective, just an overall TCO. So I think we're going to see a lot more pull on the networking side than we ever have before.
Yeah, and I think in a really weird level, I'm hearing a lot of that pull that you're talking about coming from the Sienna, Lumenta, that kind of level, where you're talking about this really high capacity, low latency networking for scale across. I don't know, that's where I'm hearing a lot of it, where it's like, oh, this is real, and the requirements are being driven at that level, not so much at, let's say, the rack level. You know what I'm saying? I don't know. That's just what I'm noticing. So but awesome, gentlemen. I think this is one of the best episodes we've ever put together. We did some really tasty disagreements, which I love. Isn't this why we started this, Karl? Right? Right? Yeah.
It all started with our fundamental disagreement around the economics of AI, right?
Yes. People don't realize that. We didn't do this to come
and we're still talking about it.
Like, hey, I want you to just repeat what I just said, but you guys are awesome. Love doing this with you guys. And again, this is you guys are part of this. So thank you so much. And, thanks to the audience for listening in. And please reach out to Jim McGregor. He and his team are working on one of the biggest problems today, which is agentic economics. Taking a look at, what are the FinOps aspects of all of this? How do you stabilize the ROI argument and the value propositions around agentic applications? And of course, Curious Research, www.curiousresearch.com. Karl Freund, the mind-expanding AI Cambrian expert. Reach out to him to understand what is happening in the landscape of AI and the silicon as well as software that's changing industries and changing the semiconductor industry and pushing the AI industry forward. And also, please subscribe to our podcast. Yes, we got one of these. We're featured on YouTube, obviously, because of the YouTube placard. And check out the audio version on Buzzsprouts and your favorite podcast platform. Also, subscribe to the Next Curve Research Portal at www.next-curve.com, as well as our Substack. You can find us on Substack. And of course, all this for the tech and industry insights that matter with Curious Research and Cambrian AI Research LLC. Gentlemen, thank you so much, and we'll see you toward the end of the month, right? We got to do our March recap. So,
yep.
Have a great weekend.
Cheers.
Gentlemen,
Cheers.
Take care.